Hello everyone, welcome back to the channel. Let's continue implementing the products feature. We need to create right now the presentation module. Let's go ahead and create a new module under products feature, module, Android library, presentation, copy products feature, paste it here, and you are good to go. Don't worry about this error. We're gonna fix it later on. Delete those two lines and switch to project. Under products feature, we have presentation. Click on product Gradle file. I'm gonna delete everything from here. We're going to use Kotlin Compose under library, Kotlin Android, and we have to apply the shared Gradle plugin. And we have to activate the Compose for this particular module. Now for the dependencies, in this particular module, we'll be using products feature domain. Make sure to import products feature domain. We need health and core module. We need Compose and core UI module, as well as coil for imagery. For testing purposes, we need presentation module, Android test implementation, and we need to access for testing purposes the data layer or data module. I don't think that we have defined this before. Let's go under build source. First of all, switch to Android, products feature dependencies. Let's add here the implementation for testing. Let's call it Android test product data or Android test product feature data. Instead of implementation, it should be Android implementation. It should be here the data layer. Let's come back to the project, build that Gradle, and import Android test product feature data layer. Don't forget to import the Android test product data layer. Hit try again to sync the project. The product feature is ready to go. Let's switch to Android. You can see here the presentation layer or the presentation module. I would like to add here internet permission under Android manifest. That's all we have to do under Android manifest. Basically, how to proceed under the different modules. It's pretty simple. We already have developed the Vue3 application. Therefore, we know for sure what are the functions that we need, what are the view models, what are the events that we have to trigger, what are the components, what are the reusable components. This is how we're gonna proceed for the 3 remaining applications. Let's create here under Kotlin, presentation, a new package. It's going to be called screen. Another package for components. Under screen, let's define the first class, which is the view model. In this particular project, it doesn't matter from where you're going to start. From either the composables or the screens or the view models, it doesn't matter. For one reason, we are going to use a very good approach, which is event-driven approach. In other words, in the view model, we're going to implement internally the functionalities, for example, get products, and we have to assign it to a particular event. Let's call it get products event, for example. Therefore, we're going to create a sealed class that's going to structure for us those events. And those events going to be consumed and used in any parts of our application. In our case, we'll be using those events basically in our screen, for example, or in our reusable composables. This way, we're going to decouple the view model from the screen, which is very great. It's going to allow us to preview the composable or the screen in isolation. It makes, again, the composable or the screen, for that matter, independent of the view model. You can change the implementation, for example, of the get products and have pretty much the same outcome. Hence, it's not important with this approach whether to start from the view model or from the composable or the screen. For the sake of randomness, I'm going to start from the view model. Let's implement all the necessary functionalities and functions that we already know since we have already defined those in Vue3 application. Then we're going to implement the screens and the fragments and whatnot. Let's go ahead and create a new view model. I'm going to call it products view model. This is basically a health view model. This view model will need the use cases. Since we are going to interact with navigation, we need to inject in constructor saved state handle. Health already know how to inject saved state handle. And a rule of thumb, never, under any circumstances, hardcode the dispatcher. The main reason not to hardcode the dispatcher is pretty simple. Under testing environment, the normal dispatcher won't work. No matter what you do, it's not going to work. Your test case will fail always. Therefore, you have to use another type of dispatcher in order to run your test on. We have already done this previously under core. We have implemented the dispatchers that we have called dispatcher provider. Let's inject in constructor the dispatcher provider. By default, let's assign it to default dispatchers. I've mentioned before that we are going to adopt an event-driven approach. Let's go ahead and create all the list of functions that this particular view model will implement internally. It's going to be a sealed class. Call it product event. The name in here doesn't matter. The only thing that matters here is how to define the product event. From the previous application, we know for sure that we will need get products on next page, load products, and so on till on query change that we have already defined under Vue3 application. Nothing new here. It's just a matter of presenting and decoupling the view model from the screen. One thing that I would like to do is to gather and group all the states in one data class. It makes our state class contained and scalable. Create here a new data class, call it product state. And again, nothing new. We know for sure the states from the Vue3 application. We need the list of products, the current page, if there is an error, the search query is searching, for example, the product detail and the list of suggested products that we have done in Pinia store. Now we are just going to do stuff differently in Kotlin flavor, and we're going to use the product state in our view model as well as our composable. Now it's time to implement the view model. Let's create here a state. It's going to be of type mutable state flow. I have prepared a snippet for this matter. The type of this state is product state and import all the needed classes. Next, let's implement all the functionalities that we have defined, aka all the events that we have defined under product events. Create here a function, call it onEvent. It takes in parameter event of type product event. When event, let's add all the cases. Now let's create the private methods. It's worth mentioning for those who just tuned in under the Kotlin application, we are not trying to reinvent or think about what we have to do here. We're going to pretty much do almost 50% of the implementation, but in a Kotlin style. It's a good idea to watch the other videos so we can be on the same page and you can understand the approach that I'm proceeding with. First function that we will do, this is very easy. On clear search, set the search query to empty string and to assign the search suggestions as an empty list. It's a good idea here actually to add is searching to false. The other one on query change. Basically what we have to do here when the user is searching for an item or for a product, once clicking on the magnify icon, this will navigate the user to a new screen. The screen is search result screen. Therefore, we have to get the search query from the saved state handle. We have to pass the key and assign the saved state handle value from the query. Next, we have to update the state. Sometimes I like to use this function update and copy search query equals search query that we're going to pass from the query change. Then we have to apply the search suggestions. Now let's implement search suggestions. First of all, we have to check if the query is now empty and we have to call the use case. It is a good practice to handle job correctly. Therefore, I'm going to create here a variable of type job. Let's call it current job. Let's initialize the current job to null. Basically what we have to do here, it is a good practice, as I said before, to cancel any previous job and assign a new one. We'll use the use cases and call get suggested products. We need to pass in arguments the query. After we have to wait for the user to finish typing, for example, the title. Therefore, we're going to use debounce. Let's debounce the operation with 800 milliseconds and let's collect the resource or the values. I'm going to switch to dispatchers input output and the whole thing will be under the view model scope. I'm going to name here this parameter resource and we have three cases basically. The first one, resource.loading. The second one, resource.success. The last one, resource and error. For loading, we're going to set is searching to true. For error, we're going to assign is searching to false. And again, the error from the resource.error. Now for the success, I'm going to put it in between. We're going to update the state with the result from the API call. Because it's nullable, we're going to assign as a default value empty list. And is searching, it has to be false. That's all we have for search suggestions function. In order to use the functions, we have just to call the event, which is pretty good. The next function, search products. The search products function will be called as soon as we are entering the composition and we have to retrieve the search query from the saved state handle. And because it could be empty, we're going to assign an empty string as a default value. If the current page, because here it's going to handle pagination, we have to check if we are in the current page or the current page is not the last page and the query is not empty, then we can proceed. As usual, cancel any previous job and assign a new one. Use cases. The use case in question is search products. We need to provide here the query from the saved state handle and the current page. Since we're going to use in this application infinite scroll, we have to make this check. This check is mandatory. Otherwise, we're going to end up with a higher index than the last page. Next, let's collect all the data on each with the same way on dispatcher's input-output, launch in view model scope. Let's name here resource. In case of resource.loading, we're going to update the state is page loading to true, because if you do remember under the Vuetify application, this is the search results screen. We're going to call this function in search results screen. Pretty much it resembles to the home screen. Is page loading to true? For the success state, we have to get the products, and for the last page, it could be from the last page. Otherwise, by default, it is 1 and page loading equal false. Now we have to add the previous products list to the new list of products from the API call. Let's call here a value. I'm going to call it new list is the previous product list, and we're going to add the new one, resource data. Because it's nullable, we have to assign by default an empty list, and the products will be the new list. For the error, we're going to set page loading to false and error from the resource dot error. The next function, load products. We need to get the product ID from the navigation. Therefore, we have to get the product ID from the saved state handle, cancel the previous job, and assign a new one. From the use case, we call get products, and we assign the product ID on each, switch to dispatcher.input-output, launch in view model scope ID. Let's name this to resource, and we are good to go. Loading state will set is page loading to true. Error state is page loading to false and error from the resource.error. Success state will get the detail of the products from resource.data, and we set is page loading to false. On next page, it's pretty simple. We're going to increment the current page by 1. From time to time, try to reformat your code. The last function that we have to implement is get products. We have to check if the current page is not the last page, cancel the current job, and assign a new job from calling the use case get products. On each, as usual, dispatcher's input-output, launch in view model scope. We're going to get the list of products from the pagination, assign the old to the new one as we have done in search products right here. And for the rest, nothing substantial. And that's all we have for the products view model. At this particular stage, you can go ahead and create your screens or reusable components. Or for those who started with screens, they won't need actually the implementation of product view model in order to display, for example, the preview for a specific composable. Let's create the first screen or the fragments, products fragments. It is a composable. Call it products fragment. The obvious thing here is the state. As I've mentioned before, you're not going to inject here in the composable an instance of view model. Therefore, we will use the event that we have declared before on event. And from the event, we can call the function that we want. I would like to experiment with some new stuff here. Instead of creating products fragment and product search result with the same thing as we have done in Vuetify application, I'm going to create here a flag indicating which part of the UI we would like to interact with. If you do remember under Vuetify application, we need to click on a specific card in order to navigate to the product detail. Therefore, I'm going to hoist the function on view product. From the same Vuetify application we have on toggle wishlist, and we have to access the authenticated user. The entire screen consists of a grid layout that we have previously defined under core UI. We're going to use this particular composable, and I would like to have grid layout to be variable according to the screen size. The numbers of items per row according to the screen size. For example, under small screen, just 1 item per row. Under medium 2, large 3, and extra large, let's say 4, for example. We have defined previously under core UI, get screen size. let's create the per row value that's going to hold for us the number of rows or number of items per row. For small, I'm going to assign 1, medium 2, for large and extra large 3. After the composable is ready to go, we're going to load the data. Therefore, we're going to trigger the event products event.getProducts. Since this particular fragment doesn't handle only the normal pagination and it handles the search pagination as well, we have to test here if search is enabled, search products, otherwise get products. And since we are dealing with infinite scroll, we need to do another launch effect that should call the event on next page and load the next page. For the dependency here, it is should paginate the state whether we should go to the next page or not in order to trigger the event on next page and get products. In order to do so, let's add here a new parameter. Let's call it should paginate. Is search enabled false, should paginate to false. For the dependency of launched effects, when should paginate from true to false, we need to check if should paginate and the page is not loading. Therefore, we're going to call the event on next page and call the same thing as we have done here on event. If is search enabled, we'll trigger this event search products, otherwise we'll trigger get products. Now we're going to build the composable or the screen. First of all, if the loading indicator or the page is loading and the list of products is empty, we need to show a circular progress indicator. And for testing purposes, I have added a test tag. I'm going to call it loading indicator to access the circular progress indicator in our end-to-end testing. Now we distinguish between 3 states. The first one, we have an error. We're going to show a warning message. When the page is ready, we're going to show another warning message telling the user, hey, we could not find anything or the list of products is empty. And for the other case, it should be the grade or the list of our products. For the case when the list of products is empty, we're going to show the same warning message. Otherwise, we will show the list of our products. I would like to add a colon here to represent the grid layout as well as the circular progress indicator when the user is hitting the limit or is on the bottom of the screen showing a circular progress indicator. I'm gonna add here the grid layout. What we have to provide here is very simple. Colons per row, the items, states, and products, and a modifier. This whole grid layout should occupy the max size. The parameter is products preview. We don't need actually the index. Here we have to add a to-do. Product card goes here. Underneath the grid layout, I'm going to add a circular progress indicator. And I want to add a testing tag for the circular progress indicator in case we want to interact with this composable in end-to-end testing. Let's go ahead and create the product card composable. And again, with the same logic, we're going to be inspired from the Vue3 application to fill the needed parameters. As usual, we need the products. We need to check if the user is authenticated in order to show the toggle button with the product in wishlist on Vue product to hoist the method to the parent composable, which is products fragment on toggle wishlist and the modifier for reusability purposes. This composable consists of a card and an image under colon. And because we need actually to place above the image another composable, which is the toggle or like button, if you will, we need to place those or to wrap those with a box composable. And we have to check here if the user is authenticated. We can show the composable that we're gonna call likable button, for example, to do build likable button composable. And we have to place this over the network image. First of all, which I like to do before I forget, the content description. To access the string resource in composable, we have to create here the context, local context, and current, and we can access the content description. For testing purposes, I will add here the product's ID and the title in the placeholder of the content description image. Now for the content scale, crop, the data, in our case, it's the URL or the thumbnail, and because it's nullable, by default, we'll assign to the data a painter resource and the ID, which is basically the default SVG file. I think it's called select your item shopping, whatever. This particular one. For the crossfade, basically 1 second. This composable should fill the max width. For the max height, just 75% of the max height. And it has to be clickable in order to trigger the animation, bringing the likable button from the right to left. Let's add some content description under semantics. it bothers me. I have to provide the other dependencies, loading components and error components. As I said before, I'm going to add semantics here. For the content description, for testing purposes, I will add the title here from the content description that we have defined under strings, products card image button, which is good for testing. The loading components that should be placed for loading indicator is a circular progress indicator. The error component, when there's an error loading the image, it's just going to be an image showing this image as a fallback or whenever there is an error. I want to check one thing under the composable network image. Make sure to have here the modifier, not like this. It should be the default modifier, not the modifier from the current composable. With that out of the way, let's continue products card. So we are now out of the box. Let's place the rest of the composables under another column, just a space between the composables. The first one is the title, nothing substantial here. The other composable, price, and the learn more button. It consists of a button and a text. It should be underneath the price value. In this button, nothing substantial. On click, we're going to trigger onView products function. For testing purposes, I added here semantics and the content description. This content description, which is learn more button for placeholder, will be replaced by the product title. And we can access this button in our end-to-end testing. Our composable is ready to go. Before moving to the products fragment, we need to implement another composable, likable button. The first parameter of this composable, whether it's liked or not, let's hoist the method whenever we click on this particular composable. I'm going to call it onLikeClick. Add the modifier, an icon size, by default, let's say 26 density pixels, and a content description for testing purposes. The entire composable consists of an icon button. On click, we're going to trigger onLikeClick here. Let's assign a modifier. Let's add the padding and the shape of this rounded corner 25. It's going to be rounded with a background surface. We have to place here the icon that we would like to use for the paint resource. It depends on the value of isLike. If it's liked, in this case, we're going to import the R from core UI and heart, otherwise heart outlined. Let's assign here the content description. Since we are going to use the animation, let's give here a modifier and use the required size. Let's leave it empty for now. For the tint color, and again, it depends on the state of isLike, material theme, and we're going to assign it to error, otherwise on surface. Now, I would like to add the animation, as I said before. In order to do so, it's going to be basically a pulse animation. I'm going to create here a variable if the animation has been triggered or not. And I will use, remember, savable as initial value, false. Once clicking on the button, we have to increase the size of this particular composable. Therefore, we have to assign here a value. I'm going to call it target width fraction, which is the target for our animation. In this case, we will use animate density pixel as state. If the animation is starting, in other words, did pulse, I will increase the icon size by 10 density pixels. Otherwise, just the default icon size. Now let's declare the animate density pixels as state. By animate density pixels as state, we have to provide the target value, which is the target value. As soon as the composable is ready, I'm going to animate the composable. Therefore, I'm going to use here launched effect as a dependency whenever the pulse changes or switched from true to false and vice versa. To make the animation appealing, I'm going to add here a delay. 200 milliseconds will do. And I will switch from did pulse to true to the value false. How to launch basically the animation here. Whenever the user is clicking on this button, I will surround this block with run blocking. I'm going to assign did pulse to true to start the animation and onLikeClick afterward. For the size of the composable, it should be relying on the animation itself. Animate density pixels as states. So I think it's pretty straightforward. Let's write a preview for this case. I just prepared a preview in advance. I'm going to change it on like clicked. We're going to show the composable in the preview, but I want it to be interactive. I'm going to add here a state, but remember savable, if you will. Once clicking on like, I'm going to do is like. We're going to toggle the value. Let's click the button. And you can see a small animation. It's like a pulse animation. Our component is working perfectly fine. Let's come back to the products card and let's use the composable here. likable button. The value of is liked is tied to in wishlist. We need to provide the icon size, which is optional, I guess, but I'm going to do 30 density pixels, and a modifier. This like button should be placed at the top right corner. I'm going to add here a padding, and we have to animate again this composable or this like button. We're going to bring the composable from the right of the card, creating a small animation. When we click on this particular button, what we should do, we're going to trigger the function on toggle wishlist. We pass in the parameter the ID as well as the title. For the content description, and if it's in wishlist, because we need to make our composable testable, if in wishlist, the content description that should be used is content description in wishlist. So pretty much we're going to do the complete opposite. We will use the context, and it's going to vary from whether it's in wishlist or not. We need to add here a second parameter, which is the product title, or a second argument, which is the product title. Now it's time to use the animation. With the same manner that we have done in the likable button, I'm going to create here a state controlling whether the button is in frame or not. I'm using remember savable in order to handle configuration changes. The target value, so whether if it's in frame, we're going to assign this target to -10 density pixels. Otherwise, let's say 65 density pixels to make it outside the frame. Declare the animate state as state. The target value is the target, and we are good to go. We have to launch the animation once clicking on the network image. Let's come back to the network image. Under clickable, we will toggle the value is in frame. Now to set the position of this particular likable button, under the modifier that we have done, let's use offset X, and the value of this offset X, it is animate density pixels as state, and this composable should be top of the network image. Therefore, I'm going to use set index. Let's assign 1. For testing purposes, I'm going to add semantics here, the content description, and the content description should be used for the toggle wishlist in order to test if this button is toggled or not. We will use this content description toggle wishlist. We have to pass as an argument the product title. I think that's pretty much it for our product card. I have prepared an interactive preview in order to see if we have correctly implemented the product card. This is the products preview. Basically, I've added a state here in wishlist, allowing us to toggle on and off the product from the wishlist. Just to animate the toggle button, I used the mock data and I picked the first element. On toggle wishlist, we're going to toggle the wishlist or the value. Now beforehand, we need to start our service, exam server. Make sure your server is up and running. Make sure your IP address, you have set the correct IP address here. And run PHP artisan serve. Why I did that, you may ask, because we need to see the image from the preview. All right. Now let's come back to the Android Studio and run under the device. This is the product card. And if we click on the network image or the image, not the card, but just the image, you can see the button coming from outside the frame with a small animation. And we can trigger or toggle the value in wishlist on and off, which is great. Our composable is working perfectly fine. Let's use the composable under the products fragment. This is the products preview. In arguments, we need to assign is authenticated. So the value, if it's authenticated, is pretty straightforward. It's authenticated. If it's not null, it is authenticated. The value in wishlist, if the user is not null, we can access the in wishlist, and we're going to apply the function any to filter. Basically, products ID equal products preview.id. In this case, the product is in wishlist. Otherwise, by default, it should be false when the user is not authenticated, of course. View product is on view product, on toggle wishlist, and the modifier, I'm just going to add here fill max width with the padding and add some content description for testing purposes. I would like to identify each card individually. Therefore, I'm going to use the string that we have defined from the string resource. And we need to create here a context and come back to this. The content description card, we have a placeholder for the wherever we're going to put from the argument. And the argument in question is the title value. I think that's pretty much it for our screen. Now we can safely preview this composable without the need of creating an instance of the view model. If you decide to create a view model or to inject a view model here, under the preview, you have to create the view model, and the view model has another dependency, which is use cases. And the use case has another dependency, which is the repository. And the repository has another dependency, which is the API service. And the API service has another dependency. And the repository has the second dependency, which is the database. And you're going to go on and on and on, which is not good. That's why this event-driven approach is good, and it decouples the screen or the composable from the view model. I just want to make sure if there is nothing that we should handle in the case of search is enabled. I think our composable is ready to go. I have prepared a simple preview for this. Let's use this preview. We're going to show the list of the products from the mocked data, nothing substantial. Let's run this preview. I assume that the user is not authenticated. And this is basically the list of our products from the mocked data. And we have the circular progress indicator is shown whenever we are on the bottom of the screen. Let's flip the size or rotate left, for example. When rotate, which is very small, let me... All right, once rotating the device, we have, instead of 1 item per row, we have 3 items per row. I think it's fine. I guess that's pretty much it for the first section of our presentation module. For the next video, we're going to implement product detail screen, and we will conduct the integration test for view model. We have to make sure that our view model is ready to go and tested under our criteria. Pretty much the test of our view model will have the same test cases as the test of the repository implementation. I hope you have learned something new. See you in the next one, and happy coding.